Now, next question, 4. Okay, we have got a cyclist and a car. Okay, so you got to read this question carefully. The first 4 lines of the question reveal there are a few things that we need to kind of consider as we go through the question. So they both start off stationary at the traffic lights, so they're not moving. That's that point there. The light turns green, and then the race starts. Okay, so that's as soon as the race starts, it's at 0 seconds. Okay, so why did it take 0.8 seconds for the race for them to start increasing their speed? Both of them start increasing their speed at 0.8. Clearly, it takes some time for them to register the cyclist and the car from the instant the light changes. So the light change, then they press the pedals or start pedaling, and as a result, the bike and the car start to move. So there's a bit of a reaction time before that happens. So the first 0.8 seconds is a reaction time for registering the lights have actually turned green. So they see the lights, then it takes a bit of time for them to press the accelerator or start pedaling. So that's where that delay is. So how long does it take for the instant the light change to go to green for the car to reach the same velocity as a cyclist? So same velocity as cyclist. There we go. Go down around about 6.8 seconds. And the other thing to note is that this graph shows up to around about 11.8 seconds, and that is the instant they are level again. So what happens is the car and the cyclist get to the same position as each other in space, so they level again. So they've traveled by, for this graph, it represents at 11.8 seconds, the cyclist and the car have traveled the same distance because they are level again. They're right next to each other. Okay, so here it says determine the distance between the cyclist and the car at this time. Okay, so at 6.8 seconds, we go across, we work out the area underneath the car, we work out the area underneath the cyclist, so that's a triangle for the cyclist and a rectangle there. That's the area we work out for the cyclist, and for the car it's just this triangle here, and I've worked that out separately. So for the car it's just a triangle, half times 6 seconds, so it's 6.8 minus 0.8, so that's 6 seconds for that triangle. Height, it's 9 going across, so it's a half times 6 times 9, and that's 27 meters the car travels. The cyclist, we've got 2 areas to work out. That area there, that's a 2.8. Okay, so that's a 2.8, and that's 0.8, so that's 2 seconds times by 9 times by a half, and then it's 6.8 take away 2.8, which is 4 seconds, times by 9 for the rectangle, and we get a total of 45 meters. So the cyclist travels further than the car in the first 6.8 seconds. By how much? That's 45 meters, take away 27 meters, and that is 18 meters. Okay, now what is the relationship between the average velocity of the cyclist and the average velocity of the car? Now, this is kind of a trick question. How do we work out average velocity? It's the total distance divided by the total time. So because they end up at the same place at 11.8 seconds, as it says in the question, they level again. Okay, so they traveled the same total distance after 11.8 seconds. They took the same amount of time to get there, so the total distance is exactly the same. The time is exactly the same, so they're gonna have the same average speed. Okay, so the total distance divided by the total time. And that's a bit of a trick question.